Hey everybody, Mr. Haircut here. Got a quick video on linear speed and angular speed. Should be pretty great. Here we go. It's time for math with Mr. Troy. All right, so first, linear speed. Take a look at these four wheels here. They're set up right now to demonstrate linear speed. Now, linear speed is defined as arc length over time. So think about that this way. As the wheel rolls, it's traveling however long upon its rim over a certain amount of time. That might be feet per second, miles per hour, meter per second, but it would be some measurement of how far is the outside of that wheel traveling over a set amount of time. The other speed to think about is the angular speed, as in how much is it rotating per a given amount of time. So pay attention to this arrow right here. That would be 360 degrees per 2 seconds or something like that, right? And we could certainly go faster, or we could certainly go slower. So one of those is angular speed and one of those is linear speed. Now, I want you to imagine that you're holding the back wheel of a bike. And you spin it and you spin it and you spin it and you spin it. And then when you let it go and you drop it on the ground, that bike wheel takes off and goes in a straight line. Now, I know that there are lots and lots of things to think about, like friction and whether it will balance and things like that. But before we get to those, we have to start with this. Okay, so we've got a very, very simple problem here to start off with. The blades of a wind turbine are 116 feet long, and the propeller rotates at 15 revolutions per minute. We're going to use revolutions per minute a lot in this unit, because that's something that gets used a lot in the real world. RPM, or Rs PM, if you so choose. So the first thing it says is to find the angular speed of the propeller in radians per minute. We've already been given an angular speed because we were told how many revolutions or how many full circles the propeller blades would make in a minute. So they've asked us to find the angular speed in radians per minute. So all we have to do is just do dimensional analysis to do a unit conversion. So we're going to start by writing out our given rate. Then we're going to multiply by a conversion factor. In this case, the conversion factor is 2 pi radians per every revolution. Remember, a circle has a circumference of 2 pi, and there are 2 pi radians in a circle. When we multiply that together, we're going to get 30 pi radians per 1 minute. And that is the angular speed of the propeller in radians per minute. Suppose we wanted to go a little bit further than the question asked. We might want to, say, figure out how many degrees per second this is going. We would do a similar unit conversion. So, for example, we might start with our 30 pi radians per minute, and we would want to convert radians to degrees. So we would multiply by 180 degrees on top and 1 pi radian on the bottom because that's our conversion factor. Now we need to get from minutes to seconds. We want degrees per second as our final answer. So we want degrees to be in the numerator, which we already have, and seconds to be in the denominator. So we would multiply by 1 minute as 60 seconds. The minute on top and the minute on the bottom would cancel each other out, just as the radian on top and the radian on the bottom would cancel each other out. When we do that, we get 90 degrees per second. Those measurements could all be useful to us for different reasons: revolutions per minute, radians per minute, or degrees per second. It depends on the context of the problem. To find the linear speed of the tips of the blade, I'm going to start with the information that I already have, which is to say I'm going to start with 30 pi radians per minute. Now, I need to turn radians, an angle measure, into feet, a linear measure, or a measure of the circumference. So to do that, I remember that 1 radian equals the length of the radius. So in this case, I'm going to multiply by 116 feet per every radian. Now, there are 2 different directions that I could go here. I'm going to start by going to miles per hour, and then I will also go by feet per second. Whichever one you choose to do depends on the context of your situation. If we're going to miles per hour, we're going to need to get to miles. So we're going to need to multiply by the fact that 1 mile is 5,280 feet, and that there are 60 minutes in every hour. If you're having trouble with how to stack those conversion factors, just make sure that if you have minutes on top, you're doing that to cancel out minutes on the bottom, or feet on the bottom will cancel out minutes on top. That gets us about 124.3 miles per hour. If we want to go to feet per second instead, it's a little bit easier because we're already in feet. We would just take our 116 feet per radian and then multiply that by the fact that 1 minute is 60 seconds. The minutes on top will cancel out the minutes on the bottom. That'll give us about 182.2 feet per second. All right, I hope that was helpful. You'll have a short couple of WebAssign questions to kind of help you with that, and you can see how you're doing. All right, have a good one. Hang in there.